Okay, so the third section in this chapter is Boolean function minimization. So the whole reason why we had to figure out what Boolean operations are and then put them in standard forms is so that we could understand how we can get rid of those operators that we don't need to find the minimum number of literals in an expression. Now, that's used as terms here, the minimum sum of products, or MSOP, or the minimum product of sums. And again, the sum of products means that they are, products means and, sum means or. So it's literals joined by and, separated by or. Minimal product of sums is literals joined by or, separated by and. Okay, well, this is where we start getting into picture drawing. And since we know that the triangles represent the or function, and the little mouse-looking things represent the and function. So we have or, we have and. We can now start talking about what's going to get us into the next thing. Next, we're going to talk about logic gates, and when we put Boolean functions and logic gates together, we get logic circuits. So all of this is for a reason, and it's adding up to something that matters. So the expression on the right-hand side is the sum of midterms. And the sum of midterms is just x and y, x and not y, plus not x and y, plus x and y. And so because those literals are being multiplied together, they are products. And then since we're using the and in between, then it's the sum of products, and that's where that comes from. But if we draw this, it becomes a hardware implementation, because we are now showing, instead of thinking of x and y now as 1 and 0, we think of it as true and false. And following the path, we can see that this is the outcome of all the possibilities. So there are 3 gates, 1 OR gate and 2 NOT gates. These are NOT gates. So there's x can be either true or not true. Y can be either true or not true. And it goes into 3 different ands, and that describes this. And all of those ands result in a true or not true, which is an or. And so this is a pictorial representation of this. So now we're getting into all these picture drawing. And so you can see that any expression can be written using this diagram as a hardware implementation in that function. Possible inputs is x and y. X and y can either be off or on. This represents on, this represents off, because it has a NOT gate. There's y on, y off. And each one of those, x goes into part of this OR gate, and y, not y goes in there. So that's x plus not y. An OR gate is a plus, and the thing that looks like a mouse is a multiply. So we draw this gate. Each one of the possible values are represented by those OR gates, or sums. And then we combine all of those using a product, which is an AND gate. And you can see x plus not y times not x plus y. And so this is a pictorial representation of this equation. So once we get into pictorial representations of equations, then we can work on minimization, which is what the Karnaugh map is. This Karnaugh map takes all the possible combinations and creates a minterm, saying that which minterm will be able to simplify the sum of products using this map. And the way that's done is we start placing 1 in each cell that corresponds to a minterm that is in the equation. And so each of the values that show up in an equation will be put a 1 for that cell. Okay, then the next step is to combine cells with ones in them that share edges in the largest possible groups. And so the groups can overlap, and you can see in this one, 1 and 1 and 1 and 1 are combinations. And that tells you that the resulting minimization, because we know from the previous Boolean expression that x times, because of the value 1 plus 1 or 1 times 1 is still 1, that the result is that we can simplify that expression to be equal to x plus y. Okay, hope that helps. As it gets more complicated, it still works about the same way. And you should walk through these examples to understand how a Karnow map can help you simplify an equation. We're going to move into, there are specific types of min terms and max terms like XOR, and X and. This is a gate which represents exclusive OR, which means, usually OR means one or the other or both. XOR means one or the other, but not both. And so that's a new shape that's going to happen. And so that will just change the way the Karnow map is displayed. Okay, hope it helps. And talk to you soon. Next week we'll be talking about logic games.